let's pick up where we left off last time, talking about the tidyverse. So which of the following describes the tidyverse? So the answer we're looking for here is the fourth one. Each of the first three is somewhat incorrect in some way, but this is the correct description. So it's a collection of R packages that is designed to make data manipulation and visualization tasks easier than they are in the base R language. We started learning a few basic functions from the dplyr package, and I'll just ask you one quick recollection question from last time, which is the function which is used to subset the rows of a data frame? In other words, return only the rows from the original data frame which meet some specified condition. So which function does that? All right, so people are all over this one. That's great. So it's the filter function. And the filter function works like this. We can pipe the murderous data frame into the filter function, which is the same as if we just supplied the murderous data frame as a first argument here. And so the filter function is going to look at the murderous data frame, and it's going to look at the rows where the region value is equal to south. So it's maybe a little sneaky what's happening here, because the filter function, it's a dplyr function, so it is aware of the data frame that the variable names are using to reference. And so when it sees region, it says, oh, I know what that means. That's one of the columns in the murderous data frame. So I'm going to replace that entire, I'm going to replace this token, this region word here, with the entire vector, the whole column from the original data frame. And then I'm going to compare it to south, and the double equals by default is vectorized. So that's entry by entry. It's comparing it to the string south. And then it's going to use that vector to index the data frame and return only those rows where we had true values. Okay, great. So we got these packages loaded so we can see what this looks like. And indeed, we get only the ones from the south. Okay, what are some other functions that we learned? We learned two other dplyr functions. See if folks can remember what they were. All right, nice job. So the other two functions were for select. Sorry, the other two functions were select, which is for subsetting the columns, and mutate, which is for creating, that these are not memorable names. Like mutate just means change, and all of the things are changing the data frame. So it's not super evocative. And also subsetting the rows and columns, you know, one is filter and one is select. You could imagine that they swapped them the other way and it would still make sense. So at some level, you just have to learn these. But what we're going to see is that there's not that many of them, really just 5 that you need to learn that allow you to do almost everything that you need to do, because they compose together very nicely. So it's sometimes called the grammar of data manipulation. The idea being that you have a few basic building blocks or words and rules for combining them that allow you to achieve a very wide range of expression. Okay, in any case, for this select and mutate business, here's an example which kind of combines some of these operations. So we're going to start with the murderous data frame, and we're going to use the mutate function to add some columns. So we want to see the murder rate. We'll need to build that out of the existing columns, total and population. And we'll also compute the rank. And with the mutate function, a really nice thing about the way this works in R is they do execute one at a time. So once we compute rate, we can then, in a subsequent argument of the mutate function call, go ahead and compute some function of rate, for example, the rank. So we'll be computing for each state what its rank is with respect to murder rate in this data set. Then we select the state and rank columns, because let's say we only want to know those 2 columns, or we only want to see those 2 columns. Use the select function to do that. And then lastly, we use the filter function to select only the states that start with the letter M. And this kind of requires us to know or figure out that the function starts with is the vectorized function, which checks whether the first letter in a string is whichever specified argument here in the second position, in this case, M. And one thing that's I think kind of cool about this is it reads pretty smoothly. Once you know that, you know, this thing is a pipe operator, I think it looks a little bit funky the first time you see it, but otherwise it kind of almost reads like English. You can see that something called rate is being created here, defined as total divided by population. Select, sort of together with these variable names, suggests that you're selecting certain variables from the data frame. And filter starts with M, also very much suggests what we're doing here. So this does not require knowledge of R really to make a solid guess of what's happening here. And that's part of the vision. Yeah, here's a great question from Kent. So is there a handy list in R for things like starts with? And I would say one of an excellent collection of cheat sheets on the RStudio website. So you can just Google RStudio cheat sheets and check out some of those cheat sheets. They're beautifully done. They're done by people who really know the language and use it, and therefore are in a good position to say what's important and how should things be organized. So I highly recommend that if you get more into R. We haven't done that yet because I don't want to overwhelm you with all the things. You sort of want to learn them and then start referencing them on a cheat sheet to remember them quickly, because again, otherwise it could become overwhelming. But nevertheless, that is a good place to look for keeping track of these sorts of things. Okay, here's a small exercise. Again, just reviewing what we did last time before we get started with the new stuff for today. The prompt is to write some R code which returns a data frame showing the small states in the West. So suppose that small here will define to mean having a, sorry, it should say it should say a 6-digit population rather than 5. All right, so let's look at people had of different solutions. Okay, so here's a nice one. So we start with the murders data frame. We pipe that into the filter function and only select the small states first. So we're subsetting the rows now so that now we only have the small states. Then we pipe that into the filter function again to select only the states in the West region. So this is going to work. The thing, if you look at this, that you think, well, it'd be nice if we could shorten it a little bit, is if we could just put these two conditions together. And there are a couple ways to do that. We didn't talk about this one, but multiple people used it. So I'll just bring it up so that you can see it. The filter function does allow you to supply multiple conditions separated by a comma. So this is an option. We can say filter region equals West and population less than 1 million. That works fine. There's one more, which is more consistent with what I presented last time, and I'm not seeing that one here, but I'll just share with you what I have. So the other thing you can do using some base R functionality instead of using functionality built into the filter function is put the and sign here. So this is going to element by element join this vector, which says for all the way down the data frame for every row, which ones are in West and which ones aren't. So this is going to be a sequence of trues and falses. And then here, the population less than 10 to the 6th, that's another such vector of logicals. And then we're conjoining with this ampersand. So that's going to say in each row whether both conditions are true. But in any case, all of these are valid. And yes, thanks for just sharing that message. So that was a mistake on my part when I created it. And I didn't want to message that correction immediately because when I send these question messages, it opens up a new question and for folks to respond right after that. And I didn't want to interfere with that. Okay, so in which regions are the states more populous on average? So what we want to do is subset the rows of the data frame in sorry, my mic is blinking, so I'm getting the impression that. Sorry about that. I think my mic might have cut out. I'm not sure because it was blinking at me, but in any case. So what we want to do is say, okay, let's take all of the Western states. So we just kind of group the rows into 4 different groups, one for each region frames that we've created. We want to average the values in the population columns. So that will allow us to say, on average, they're pretty similar or one is significantly. Okay, there was just a question here that I'd like to answer, which is it better to use the comma or the and? I tend to see people using the comma more. So I'd say that's the preferred one when you're using the tidyverse functions, or specifically the filter function. Okay, so regarding this operation, where what we want to do is sort of collect the rows into different groups based on the value in a particular column, and then average or perform some other operation to combine the values in each of the columns for those 4 new data frames. This operation comes up a lot. It's really key to having a wide expressive range when you're manipulating tidy data. And so it's really important that there be good functions for doing that. And of course, there are. So that's what we're going to learn next. The first one is called summarize. So the idea is that there are some operations that you really want to be able to perform that involve collapsing a whole vector down to a single number. So for example, the mean or the standard deviation or the sum or the minimum, these are things that you can apply to a whole vector, and what you get out is a single number. So we'll call those aggregation functions. And the dplyr verbs that they're used in conjunction with these aggregation functions are called summarize and group by. So let's do summarize first. So the summarize function will provide a way to compute summary statistics in a way that, like the other dplyr functions, is going to be intuitive and readable and works well with those other dplyr functions. So we'll look first at a heights data set, which contains, for 1,050 people, it contains their sex and their height. And what we might like to do is compare the average height of the males to the average height of the females. So here's some code which computes the average and standard deviation specifically for females. So we'll start just by introducing the summarize function. And to do that, we'll use the filter function to explicit data frame. So we'll start with the heights data frame. We'll pipe it into the filter function to select only the females. And then we'll pipe that into the summarize function. And the summarize function, it works very similarly to the mutate function, except that it's going to be collapsing these columns instead of just returning new columns. So we put in the height column to the mean function, and we store that as a value called average. And so we'll see just a single entry here instead of a whole column. And same idea with standard deviation. We plug the height value in, and the summarize function knows that what it should expect to get out here is a single number, and it'll just return that single number as it sort of the only row in this data frame. Yeah, the difference with mutate is that you're not creating a new column. That's exactly right. That has only the values that creating in the summarize call. Right. So that's why we don't just use, you can imagine, well, why not just use mutate if it works the same way? And that's, in some sense, it's sort of almost true, except the problem is you can't append a length 1 vector to a data frame that already has, 1,050 entries, because then you'd have, some columns would be long and some columns would be super short. And, you can do that in a spreadsheet, but you can't do that in a data frame, because each row should correspond to an observation. And if you're kind of sticking extra stuff hanging over to the side, that row no longer represents an observation. It represents an observation plus some extra data that you just kind of stuck in those extra cells over to the right. So this is a big difference between structured programming, like what we do in R, and the way that you might have done data science when you do things in Excel, for example. So Excel is extremely flexible, but also it becomes hard to get it to do organized things like what these dplyr functions are doing, unless you're very rigid. And the programming language kind of helps you stay on the right track and not get your data sort of muddled up. Yeah, so a few questions here. So the first one, summarize versus summarize, it supports both, so they're equivalent. So Hadley Wickham prefers the British spelling with the S, but of course a lot of our users are more accustomed to the American Z spelling, and so they just put both of them in there. Yeah, so the comment, the short vector would lead to further problems with data manipulations. That's exactly right. That's a great point. That's why we don't allow you to, in the R language, to build a data frame that has columns of different length. You really want to maintain the structure so that all of the operations know exactly what they're looking at. It comes back to clearly communicating intent. And then here's a question about the details of how the the forward arrow works. So it's an operator is the key point. So think about something like 1 plus 2 plus 3. What does that do in the programming environment? So what does R do when it sees 1 plus 2 plus 3? It sees the plus sign and it recognizes that this is an operator. And so it decides what it should operate. And in this case, the order of operations rules say that this addition should happen first. So the first thing that happens is 1 plus 2, and then the result is added to 3. Okay, so when you do this in your head, you don't necessarily do that. You see 1 plus 2 plus 3, and maybe you just immediately know that the answer is 6 without having to consciously process it. Maybe you do, but you add it up in some other order. You're like, maybe I want to add 3 and 2 first. Plus, I know that this is a commutative operator, and it's an associative operator. So I can do it in whatever order I want, and you get all to the same answer. The computer doesn't do that. It follows strict rules and does things in a consistent way. And here what it does is first add these two and then add the result to the third value here. The filter function works the same way. So it sees that this is an operator and it consumes the next expression. And it's like, okay, here I have an operator which has one value on the left, another value on the right. What am I supposed to do with that? And it knows, because it's defined in the Magritter package, that this operator positions this value as the first argument in the function call that appears in the second argument. So then you get filter of heights, comma, sex, female. So it sort of replaces it like this. And then it's like, okay, what happens next? Again, I've got two values, and the second one is or really I should say two expressions, because it's consuming these things at the level of code rather than evaluating their actual values. So it sees, okay, I've got these two expressions, code expressions that the user has written, and there's a pipe between them. What am I supposed to do? And it says, well, I know what to do. I substitute the value here in as the first argument to this function. So it ends up being equivalent to this, but we don't, and so we could write it this way and it would still run, but we don't, because it's, it's not as easy to read. You have to, I'm just looking at it right now to try to explain it, and I have to sort of find where the inside is. I'm like, okay, the first thing that happens is here. All right, there we go. And then the next thing that happens is kind of working inside out. It's visually, it's less straightforward to parse with your eyes. So that's what's going on. Okay, cool. So so what this operation that we did back up here is doing is that it takes the heights data frame, it filters to select only the females, and then it creates a new data frame obtained by aggregating the height column in these two different ways, by applying the standard deviation function and by applying the mean function. And again, the important here when you use the summarize function is you always want to be collapsing the values that you see, the column values that you see, down to a single number. And notice that we did store the result of that computation above as a variable s. So we can look at s and see what it looks like. So it's this data frame, and we can access its columns as usual using the $sign if we want. So we can do s $average, and that grabs the average value. And it really grabs the whole column, but because the column is length 1 in R, that's equivalent to a single number. So a single number is a length 1 vector in R. So all that checks out. So yes, we can look at these values if we want, if we needed to use them in some computation and we didn't want it to be a data frame. That's one thing we could do. So there's another operation that we can perform, or another sort of nuance of using the summarize function. Sorry, I think my internet connection speed is leading to some lag with the messages coming through. Yeah, okay, so yeah, basically this is just another example. We can do mean, median, median, minimum, and maximum here. And the sort of additional nuance is that you can also do multiple values at the same time. So median, minimum, and maximum, these are all what's called quantiles of the vector. In other words, you put everything in the vector in order, and then you kind of go through it and see what's sitting there when you go a certain fraction of the way from beginning to end. So minimum is what you see when you sort and then look at the beginning. Maximum is what you see when you sort and look at the end. Median is what you see when you sort and look at the middle. So these are all the same idea, but just the fraction of the way down the list you're looking changes for the different values. So these are all specific cases of something called a quantile, which just expresses that idea. You give some fraction between 0 and 1, and you say you go that fraction of the way through the vector and select what's there. So that's called the 0 quantile for the minimum, the 0.5 quantile for the median, and so on. And we can put these together if we want, like this. And the quantile function is vectorized, so it will compute the quantiles for each of the values that we specify for the same height vector. However, this isn't quite the same thing. You might have noticed that it's different. Here we have median, minimum, and maximum in 3 separate columns. And here we have range in just 1 column. So it's the same data, but it is organized a little bit differently. But we'll get to a kind of better way to do this so that we can perform this kind of operation, but obtain this kind of result, which is a bit handier, because here we would have to remember that the third one was the max. And here we can just use the word maximum to access the correct value. Okay, so here's another example of how I can use the summarize function. So we can compute the average murder rate for the whole United States. So let's see what that looks like. So again, we'll compute the murder rate, adding this new column. So again, using the mutate function to create that new column. And we might think, okay, let's just take the average. So we can average the murder rates. We can use the summarize function with the murder data frame. We could pipe this, but we just didn't here. Either way, it's the same. And we can compute a mean of the rate column. So again, what's happening is the dplyr is replacing rate with murder's $ rate, sort of doing this operation. That's essentially what's happening, except it's also choosing to return that value as a data frame, because it works that way. All the functions work that way for consistency. In any case, what we've got here is 2.78 roughly. But then also we could do it a different way. We could say, well, I know what average means. It's just, we can just total up all of the murders and divide by the total population. So that's totally fine as well. We'll see what that looks like here in a second. So we can pipe the murders frame into the summarize function and sum the total column and sum the population column, divide, and then change units here. We're using the summarize function again for that because we're collapsing this whole the whole column sum into a number, the whole population column into a number, the whole total column into a number, and then dividing. So this is an aggregation operation. It's working on 2 columns, but that's fine. We're still, the important thing is that we're collapsing all the rows in the data frame down to a single value. It's called rate, and we can run that, and we get 3.03. So that was different than 2.78. And all we did in both cases was just average. So what's happening here? Why are these numbers not the same? We just computed average in 2 different ways. All right, so this is great. So if we want to aggregate state level data, the point is that if we want to do it properly, we need to weight by population. Otherwise, we'll get this discrepancy here. Right. So, it's sort of like if a teacher grades your exam and averages your points on each page and then averages all the pages, that's different than directly averaging. Because if there's like one question that spills over onto the last page and you miss it, now you have a 0 for that whole page, and it's going to pull down your average. So same thing that's going on here. Okay, but the main point was to illustrate how that summarize function works. Now, this is a kind of small, lesser known dplyr function that's just handy to use sometimes. It's not really performing a serious operation. The idea is that we have a data frame when we compute this summarize operation. We have a data frame that represents a single number. And sometimes you want the actual number, not the whole data frame. So you want to be able to kind of pull out the number from the data frame, and that's what the pull function allows you to do. So for example, we can just pipe the US murder rate data frame that we just created, which just has that one value, and just pull the rate value out. And it gives us the value that was in that data frame. So you might think like, okay, well, what's the point of that? We already know how to access a value that's in there. We use the $sign. We just talked about that. And that's, you know, one of the first things we learned. But the point is that the $sign syntax doesn't play so nicely with the pipe. So if you want to be piping a data frame into some function that's performing some, you know, broader calculation, and you just want to grab say the rate column or the rate value from the data frame you created, you can just do pull of rate using the pull function, and it's totally fine. Otherwise, you would have to have some way to reference the data frame that's coming in from the pipe. And that, you know, you can do it, but it's kind of clumsy. So the pull function makes that a bit tidier. Okay, so if we just made this one additional pipe and pulled the rate value out, then we'd be able to see that the class of the resulting object is numeric. So you can see that here. Performed this operation that we explained we might be interested in to average the female heights and average the male heights. And we could certainly use that framework to perform this grouping operation. We could first average all the female heights and then average all the male heights, and then we would have the average for each group. However, this is really tedious, especially if you have two groups. Even with two, though, you're having to duplicate expressing your intent, which is to say, I first want to group and then I want to aggregate. Okay, so the way that this is going to work in dplyr is that we're going to use the group by function. So it's group underscore by. It's common instead of a dot to have an underscore in the Tidyverse packages. So this is kind of a deviation from the standards in base R. So we have group underscore by instead of group dot by. So let's see what group by does to a data frame. So we're going to group by the values in the sex column. And well, it doesn't look any different. It looks like the same data frame as before. It didn't pull these values together. It looks like it didn't do anything, but you can see that it did something actually, because up at the beginning, it says that the value that it returned is a grouped data frame. So somehow that's going to be useful. Certainly it hasn't been useful yet. It just changed what was printed at the top. But this is in fact a different kind of object that's poised for further calculation in a useful way. So what's going to happen is this is differently than an ordinary data frame. So if you want to, conceptually, you can think of this as being many tables, but with the rows kind of grouped together into sub data frames. So imagine pulling all the male ones together into one data frame, all the female rows together into another data frame, and then you have these two data frames sort of sitting together. And it could present like that. It could pull the male and female rows together to make it look nicer, but it doesn't, because it wastes some time to do that calculation. And usually you're going to process the data further where you never actually need to see it visually with your eyes in a separated way. But internally under the hood, it's separated these out kind of, you know, in its head, so to speak. And it's ready to do something different with them. So let's see what this actually looks like. So we pipe the heights, we pipe the heights data frame into the group by function to group by sex. And then the resulting grouped data frame gets piped into the summarize function. And we say we want to compute the average height and the standard deviation of the height. And the summarize function knows when it sees as its first argument the grouped by data frame, it knows that it should perform these aggregation operations on a group by group basis. And now you're going to have a group of individual values, one for each of these new columns that's created. And when you have a group of individual values, you can now let those values just be rows again. So what we get is another data frame that has the female row and a male row. So this is much cleaner than separately filtering on each one. We're expressing our intent directly. Take the heights data frame, group it by sex, and then for each of those sub data frames, aggregate them in a specified way. Compute the mean, compute the standard deviation. And we get this nice data frame out at the end. So you might have noticed, as Tom did, that this thing is not a data frame anymore, it's a tibble. And we'll talk about that in a second, but a tibble is it's basically a data frame. I mean, it is a data frame. It's a subclass of data frame. In other words, it's a special type, and it's specific to the tidyverse. So the idea is that there were some features of base R data frames that were undesirable in various ways, but it would change those features. So they created a new type specific to this package ecosystem. And yeah, so you should think of it as more or less a drop-in replacement of features and other desirable properties. Okay, for another example, let's look at the median murder rate for the 4 regions. So we brought up this idea earlier, and we'll actually do it now. So we'll pipe the murders data frame into the group by function so we can group by region, and then we can compute the median murder rate for each of those regions. So you can hopefully start to see, once you get used to this, it's very clean. You just express the action that you want to perform, and it just happens. So you don't have to sort of think a lot about how to structure your code beyond just directly typing what you want to happen. So again, you do have to remember certain things like what the pipe operator looks like, the fact that group by has an underscore in here, but your code, store intermediate arguments come in, all of that kind of stuff is basically handled for you by these functions only taking the bare minimum information that they need to perform their operation. In any case, what we can see is that the South is significantly higher than the other regions. Northeast and North Central are pretty similar, and then the West has the smallest murder rate by a pretty significant margin here. So this particular example is a good segue, I think, to the next topic, because you look at these columns and you think, well, I don't really want to have to sort them in order in my head. I'd like for them to just be in order when I'm looking at them. And we've talked about this at some length, how to do this in base R. It turns out this is much easier to do in the tidyverse. So I'll just show you here, and then I'll give you the example I had prepared. But just for this little data frame, we can use the arrange function, and we just say which column we want to arrange by. So we can arrange by, for example, this new one we just created, median rate, and now they're in order, sorted from smallest to largest. So it was really as simple as that. We just remember that the sorting function in dplyr is called arrange, and then that's pretty much it. We just tell it what we want to arrange by. So here's another example, the one I actually had prepared. We're going to arrange the whole murders data frame by population. So again, similar idea. We pipe murders. The question is, does order change sleigh? And the answer is well, it's sort of somewhere in between the two. So it returns a new data frame rather than changing the original one. But in that new data frame, the order of the rows is actually changed. So it's not just printing that way on our screen. It's actually doing that. Okay, great. So right. So if we pipe murders into the arrange function, and then from there into the head function, so we just see the first few, we get the states in increasing order of population. So we did this before, and remember there was a lesson to learn, which is how do indices work? How, when you index a data frame, how does that work? The order function versus the sort function. And, you kind of had to fit all those pieces together, right, to get this to happen. And here you really don't. You just need to remember that it's the arrange function, and it just works. All right, so if you want to arrange by a different column, like the rate column instead of the population column, you can totally do that. You just change the name here that's being supplied to the arrange function. If you want to order in the other way, so here we're going smallest to largest, sometimes of course you'd want to order from largest to smallest, you can use the descending function, DESC. And if you call the descending function on a name, then the arrange function, it creates a new thing that the arrange function knows how to deal with. And it's going to sort in the opposite order. So here we're going to go in decreasing order of rate. So the biggest is first. So we have this huge murder rate here from DC, and then it goes down from there. Now, one thing about sorting with data frames is that you can sort by multiple columns. And the idea is you want to sort by the first column, but maybe there's a tie in that column and you want to use a second column to break from just, yeah, this is different from sorting first by the region column and then by the rate column, because in that case, you would not be preserving the organization by region. You would basically, it was essentially equivalent to just sorting by rate. You need some special way to specify, like sort by this, but if there's a tie, then use this as a secondary consideration. And the way that works with the arrange function is we just supply a second argument. So we just separate the columns with commas, and it does that for us. So if we arrange by region first, we'll see that Northeast comes first. That's alphabetical. Or rather, it's based on the order that the whatever order is specified when this factor is created, which by default is alphabetical, but could be something else. And then if there's a tie, we separate by rate. So we see that we have these rates in order because at the top, they're all Northeast. But if we were looking further down the data frame, let's do that here, we would see that we have the South next, and North Central, and then West. And incidentally, this is not alphabetical because you see North Central and Northeast are separate. So that means that this factor was created with a special order to the levels. Okay, so here's another function called the top n function. And the idea is we're just generalizing the head function. So top n allows us to specify the proportion that we want to see. So we can say, top n of 5, and we also have to say which column we're interested in computing the top n for. So we say top n of 5 comma rate, and that looks at the rate column, picks the top 5, and returns only those rows. So this is kind of like head, except it doesn't it doesn't require us to sort the data frame first. It's implicitly handling the sorting when we tell it which column we want it to look at. And yeah, so the point is that we didn't actually sort the rows in the data frame by rate. We just filtered based on the rank of the rate. And all of that was handled behind the scenes for us by the top n function. So this is following up on the question that came in earlier. Okay, so again, when we group by something, what we return is a group's data frame. And a group's data, let's look at what a group's data frame actually is. Because you might think, okay, it's just some other type in R, whatever. But there's a richer story to it. So for one thing, it's specifically a Tidyverse class. So it's not something that belongs to the base R language. And this indeed was one of the reasons for introducing tibbles. You can't tack auxiliary data onto a base R data frame. If you want data to be there, it needs to be in the data frame. And information like what are the groups that have been selected, so that when we call the summarize function, it will appropriately work on a group by group basis. That kind of stuff needs to be supplied. It needs to be available in the data structure and not just in the data frame. It needs to be stored separately. So there was need for a new data type that allows you to do that, and Tibble is what was created. And so here's what you can see when you call the class functions. This is a new thing. We don't get just one class, we get 4. So it's telling us it's telling us that this group by return value is a data frame. And more specifically, it's a Tibble. And more specifically, it's a Tibble data frame. And more specifically than that, it's a grouped data frame. So the idea is that each of these is a more specific type than the one to the right. So this is a generic Tibble. So anything at all that is a Tibble, which includes some more exotic stuff, would be considered belonging to this class. Whereas a Tibble that's actually directly emulating a data frame is belonging to this class. And then this is an even more special type than that, called the group's data frame. And the summarize and group by functions always return that kind of data frame. And that brings us to time. So thank you for being here today. I hope you enjoyed this lesson, and we'll pick back up from here for next time.